Hey, hello Math 1. This is our little introductory video for the week 7. This week you'll be solving systems of equations algebraically. Let's look what's coming up. So this is our introductory video for the week. I looked at everyone's feedback and hopefully this will be an improvement. We're going to go over the tasks you have for the week. We're going to go over how it's connected to some previous material you've seen, and we'll also work through some examples. Let's get started. So, your objective this week is solving systems of equations algebraically. So this week is more about a method about how you do a certain task, because you've done this work before. This week you're going to learn 2 new ways to do the same material. More details coming. Your learn task this week is in iReady. Because there's 2 methods you're doing, it just so happens that the iReady lesson is going to go over one method, substitution method. Your do activity, which is to look at flipped algebra and take notes and do the practice problems, just problems 1 through 8. I haven't assigned all of them this time. But in your do activity, you're going to have to show your work and paste it into a Google slideshow that's up on Schoology. So everybody should be submitting their work through a Google Slides show this coming week. Your Connect activity is to meet up next Thursday at 2 o'clock is our time, if I remember correctly, and everyone should be continuing with their MyPath. So let's now talk about solving systems of equations algebraically by first looking at some previous material. So about solving systems of equations algebraically. First of all, a system of equation. That's the situation where you have 2 or more equations and 2 or more variables. Something that might look like this. And in the past, we've solved these things graphically. So remember, if you have 2 lines, oh, I meant to have 2 lines. Oh, I've got 2 lines. Say you have 2 lines. Remember, if you have 2 straight lines, how many different arrangements are possible? Well, one arrangement is that the 2 lines are parallel. In that case, do they cross? No. You could have 2 lines that are directly on top of each other, right? And then do they cross? Well, yeah, they cross everywhere. So every point that's on an answer for one equation is also an answer for the other equation. The other possibility is that when they only cross in one place. And where they cross, remember, is the solution to the equation. So remember, given a system like this, we graphed each line and we noted, boom, where the lines cross, that is the solution. So in this case, the solution to this system is the point 1, 2. Question. What if the lines crossed in a not so friendly place, like between the lines in the coordinate grid? It'd be hard to know visually how to do that. This is the reason why we need some other methods and why you have to learn how to solve algebraically. There's 2 methods you're going to learn this week: substitution and elimination. Let me remind you again. And the iReady lesson will cover the substitution method. The flipped algebra lesson will cover the elimination method. So make sure you cover both of these. Okay, it's the helping hand of Mr. O here. Let's get him out of here. Let's talk about substitution. So in math, when they're talking about substituting or substitution, they're talking about swapping equal things. So, big picture, what are we talking about? If A is equal to B and B is equal to C, then there's a relationship between all 3, and we can say that A is equal to C. Let's look at it this way. If A is equal to B, like we said, and B is equal to C, all we're saying is that A and C are also equal. It's called a transitive property. You don't have to worry about that vocabulary right now. Okay, so let's look at a number example. Say we know that 7 is equal to 5 plus 2, and we also know that 7 is equal to 3 plus 4. Well, since 7 is equal to 5 plus 2, I'm going to swap out this 7 with 5 plus 2, and sure enough, 5 plus 2 is equal to 3 plus 4. So there's your number example. So how does this translate into algebra? Because this is what it'll matter for the work this week. Say you have a system of equations, y equals 2x and y equals x plus 1. The nice thing about this arrangement is that one variable is all set by itself. Sometimes you have to do some manipulating to get a single variable by itself. Well, since these y's are the same, I'm going to swap out this y with that, and now I can write it as 2x equals x plus 1. Hey, single equation, single variable. I can subtract x from both sides, and I have x equal to 1. I could take this, boom, plug it right back in there, and sure enough, 2 times 1 will make y equal to 2. And so there's my solution. My solution xy is going to be 1 comma 2. There you go. Let's look at elimination. So the idea behind elimination is that you add equations so that a term you are focused on cancels out. Let's look at a number example real quick. So 4 plus 6 is equal to 10. Yeah, sure enough, Mr. O. But isn't 21 minus 6 equal to 15, right? 21 minus 6, that's equal to 15, right? Well, let's think about what would happen if we added these two equations together. That means we're going to add the left side, all the left side pieces together. We're going to add all the right side pieces together, just like we do when we're working with equations. So what I'm going to do first is I'm going to put all the left side stuff together. And what I'm saying is 4 plus 6 plus 21, right? Because I'm adding these two equations, minus 6. Well, that's equal to, on the right side, 10 plus 15. Well, I noticed conveniently that this plus 6 and that, I think it was a negative 6 as integers, they drop out. And I'm left with 4 plus 21. And then the right side, 10 plus 15 is 25. And sure enough, 25 equals 25. So I had the equations. And when I looked at this way, sure enough, the two sides remained equal. Well, this is what we're looking at right here. Hey, won't those two terms cancel out? And there you got it. 4 plus 21 is 25. 10 plus 15 is 25. Okay, we're going to take advantage of the same kind of thinking algebraically. And there's kind of two situations that I'm going to highlight here. So consider the following two systems. Negative 4x minus 4y equals 8, and negative x plus 4y equals 12. So this is first system, and I'm going to contrast it with another system over here. Negative 5x minus 6y equals negative 3, and 2x plus 4y equals 6. So here's two systems of equations. Oftentimes, in the notation of this kind of work, they label each equation. Sometimes you see it like these little circle 1 and 2 might be A or B. But the point of this is just so later on in your writing, you know which equation you're referring to. So I'm going to call this the friendly. Matter of fact, friendly is green color, right? I'm going to say this is kind of a friendly system. Not so much over here. Why is this friendly? Well, let's look at this. If I was to try and add up these two equations right here, I would notice, hey, check it out. Those two things, the way it's set up, everything's all nice and lined up, right? The x's are lined up with the x's and the y's are the y's. The equal signs are lined up. Won't those drop out? Yes, they will. And I have negative 5x is equal to 20. I can solve that easily, right? Divide by -5, both sides. And I've got x is equal to -4. Then I could take the negative, I could take this, I can plug it back in, and I can find y. Well, let's look at this, not so friendly example. Can I just add these together and have a nice situation like this? No, because these are not opposites, are they? So they won't drop out. So what you're going to have to do in this situation is you're going to have to adjust one or both of the equations so that things can drop out. So in this case, it looks like I'm going to have to change both. Sometimes it just depends on the terms you have. And you get to decide which term you want to go away. So for example, I think I'm going to get rid of the x's. Because if I multiply this equation 2 by 5 all the way through, won't this turn into 10x? If I multiply this equation through by 2, this will become -10x. So I'm going to distribute all my pieces here, right? And when I do that, equation 1 now looks like this. -10x minus 12y equals -6. And now I distribute the 5 in equation 2. And now equation 2 looks like this. 5 times 2x is 10x. 5 times plus 4y is plus 20y. And that's going to be equal to 5 times 6 is 30. And now I've set up a situation like my friendly. I've turned this into friendly. But I could have focused on the y as well, and I could have multiplied things through so the y drops out. But here's the two situations you're going to have to face in the elimination method. Okay, hope that helps. Well, I hope the examples helped. Remember, this week you have an iReady lesson and quiz you need to do, flipped algebra, and some of you may notice that it's flipped algebra 8.3, which actually happens to be the same lesson number you did last week, except it was flipped geometry. So that was completely coincidence. Make sure you join the academic meeting. I hope this video has been an improvement over last week, because we're always trying to improve what we do. That includes me helping you guys with distance learning. I miss seeing you. Remember, be humble, be kind. Bye for now.